Assalamualaikum and great day everyone. I am SHARIFAH AFIQAH BINTI MUSTAFFA 171142682, final year student of Bioprocess Engineering. This video is all about my final year project on removal of iron from industrial effluent by using Concorp as biosorbent. This project is supervised by Ahmad Nabil Abdul Azim and Encik Abdul Rahim from Water Treatment Plant Sungai Baru. Concorp will be used in this research due to its ability to absorb heavy metal and inexpensive raw material. The effluent sample will be collected in Water Treatment Plant Sungai Baru. In this study, two types of Concorp biosorbent will be prepared, which are modified Concorp and dry Concorp. Different biosorbent will be prepared to test the metal uptake capacity. The properties that will be determined are the morphological structure, functional groups present, and chemical information of the Concorp biosorbent. Next, the biosorbent will be tested for three different parameters, which are pH, contact time, and biosorbent dosage in order to determine the optimum condition for the biosorbents. Lastly, absorption isotherm will be studied by evaluating the isotherms, plotting the graphs, and comparing the R-square values. In conclusion, this research is expected to prepare the best biosorbent, determine the optimal condition for biosorbent and suitable absorption isotherm to be used throughout the study. So basically, these are the list of what I am going to talk or discuss in this video. Chapter 1 consists of problem statement, objectives, and the scope of the study. Chapter 2, literature review. It is discussed about water treatment process, heavy metals, iron, Concorp, and biosorption. Experimental methodology will be discussed in detail in Chapter 3. Lastly, expected results to be achieved at the end of the project and some of the references used in this project. The most common question asked is why effluent should be addressed. It is an issue faced by the industrial. It is also applied to the water treatment plant Sungai Baru. The effluent that produced every day is a concern to the plant. The effluent containment should always meet the Department of Environment DOE requirements before it is able to be discharged to the soils, rivers, and environment. What if the heavy metals containment does not meet the requirements? In this case, the effluent can contribute to a significant problem to the environment and it needs to be treated first before it is ready to be discharged. Besides that, service providers also face some problems, and one of the problems is the choice of raw materials or biomass. They are looking for a low-cost and abundant raw material, high bioabsorption capacity, good heavy metal absorbent, and eco-friendly material. Recent research have performed bioabsorption method on mango peels, banana peels, rice husks, and sugarcane baggers. The heavy metal uptakes are differ for different bioabsorbent materials used. The last problem faced is on preparing the best or new approach of bioabsorption method. First thing first, the chosen raw materials as biosorbent will be dried or treated before it is able to perform a series of experiments. The series of experiments is carried out to determine the optimum condition for the biosorbent to perform at its best. Objectives stated here are the answer for the question on how to prepare and characterize Concorp biosorbent, how does the variation of biosorbent parameters does affect the ion uptake, and what is the suitable absorption isotherm to be used. This project is focused only on treating ions in the industrial effluent. The effluent is collected from the water treatment plant Sungai Baru. The generation of the effluent is due to the cleaning and backwashing processes of the tanks. The main purpose of the study is to help SADA to maintain low iron concentration present in the effluent. In order to reduce the iron concentration, the preparation and characterization and also performance of the biosorbent will be conducted and tested in this study. Some of the important equipment used are furnace, FTIR, SEM, HEC TR6000, UVVs, and ICPMS. There are four main processes involved in the water treatment process, which are aeration, flocculation, sedimentation, and filtration. The process starts with aeration, where it brings air and water in close contact together to remove dissolved gases like carbon dioxide, and it pumps cascadely over a series of trays. Coagulant 8, alum, is dosed to enhance the floc formation before entering the flocculation tank. Flocculation is a successive process to overcome the force that stabilizing suspended particles and allow frequent collision. Flocks form will then be settled in sedimentation tank. Sedimentation is a process that helps to settle down the particles by the gravitational force. Tiny particles will be removed at filtration process. In addition, filtration helps to remove colloidal clays and colored metals. Treated water will be stored in the treated water tank before it being distributed to Langkawi. Did you know that the effluent contains a lot of heavy metals? Some of the heavy metals are iron, manganese, aluminium, silver, cadmium, chromium, copper, zinc, and many more. Industrial effluent is generated from the manufacturing process in the form of liquid or wastewater. Effluent concentrations changes every day and it influenced by the weather and chemical dose during the process treatment. Physical and Chemical Analysis Report on 24th March, iron concentration in the effluent has been recorded to be 0.93 mg per liter. The permissible range of iron for standard B is 5.0 mg per liter. The iron concentration must be always kept below than 10% as a preventive action. Only the authorized person can conduct analysis and sampling method, and only use approved instruments to perform an in situ or ex situ analysis. Anthropogenic activities introduce heavy metal in large amounts that lead to the environmental pollution and may threaten human, animals, plants, and environment. Heavy metal cannot be broken down and non-degradable. Characteristics of heavy metals are high density, high atomic number, and high atomic weight. The density of heavy metals are between 3.5 to 7 grams per centimeter cube. Most common heavy metals in wastewater are cadmium, copper, iron, silver, and chromium. Iron is commonly present in groundwater. Iron is the fourth most common element in earth crust by weight, and earth core is thought to be composed of iron. Iron can be accessed in two oxidation states, which are soluble ferrous iron Fe2+, and insoluble ferric particulate iron Fe3+. The oxidation state indicates the solubility of iron and how much electron has lost. Iron is a brittle, hard substance and classified as group 8 in the periodic table. Iron can discolorize, staining, turbidity, bad taste, and can form iron oxide in the pipe if it is present in high concentration. Recent research has been tested different bioabsorbent to various parameters such as pH, contact time, temperature, concentration, and dosage. There are three researchers stated on this slide, which are Shevendi et al., Goher et al., and Zhu et al. Shevendi, Goher, and Zhu et al. Used natural zeolite, granular activated carbon, and flowers-based activated carbon as bioabsorbent in their research, respectively. These are the results that they obtained from their research. Recent studies use mango peels, almond peels, rice husks, and sugarcane bakers, and also corn cob. In this study, corn cob is used as bioabsorbent due to its ability, low cost, eco-friendly, and reusable raw material. Corn cob is biomass feedstock with the ability to absorb heavy metal in the wastewater or industrial effluent. Anthony et al. 2017 state that corn cob has 5.1% of moisture content, 8.5% of ash content, 44.4% of carbon, 5.6% of hydrogen, and 48.27% of oxygen. Several methods have been introduced for the treatment and removal of heavy metals over the last few decades. Standard procedures used for metal uptakes are chemical precipitation, lime coagulation, ion exchange, reverse osmosis, and solvent extraction. Those conventional methods have limited to several factors. For example, chemical precipitation has the same mechanism like coagulation process. Factors that influence this method are the nature of oxidation state, pH, standing time, and presence of complex formation ion. Next, the ion exchange. With the extensive application for the softening of water and the purification of seawater, one of the disadvantages of this method is selectively available for specific metal ion. Lastly, solvent extraction or liquid-liquid extraction is a separation process that involves in transferring a solute from one solvent to another. Liquid-liquid extraction requires a large amount of solvent, multiple extraction, and long extraction time. As in conclusion, those conventional methods are ineffective in removing heavy metals at low concentration of heavy metals and selective to pH, metals, and equipment. Bioabsorption is a process that utilizes biological materials as adsorption and subjected to the interference of several factors that affect the equilibrium and kinetic. Bioabsorption is a process that independent of energy and heavy metals are accumulated or adsorbed on the active side of the bioabsorbent. Bioabsorption method is competing with other conventional methods in terms of cost of operation and installment, technologies, and waste disposal. Bioabsorbent has high bioabsorption capacity and suitable kinetics, good size, shape, and physical properties, cost-effective, good chemical resistance, and thermal stability. Two bioabsorbent types are going to be prepared and characterized, where one is prepared with acid treatment and another one prepared is without the acid treatment. This method is mainly focused on preparing and characterize the bioabsorbents and the concentration of effluent. The steps for preparing bioabsorbent with acid treatment are: firstly, collect corn cob from corn plantation and wash them with tap water to remove dirt, soils, and pesticides. Secondly, dry the clean corn cob under sunlight for 48 hours and soak them into phosphoric acid for 10 hours. Next, after 10 hours, they will be then dried in furnace at 550 degrees C for an hour. The dried corn cob will then be washed using deionized water thrice. Perform filtration and collect the residue. 6. The residue will be further dried at 105 degrees C for the total of 8 hours. Lastly, the carbonized corn cob will be ground and sieved at 250 micrometer size. Preparation of bioabsorbent without acid treatment is much more simple, which by collecting the corncob and washing them using distilled water. The clean corncob will be dried in oven for 8 hours at 80 degrees Celsius, and lastly they will be grind and sieved for the same size as mentioned before, which is 250 micrometer. For the characterization of biosorbent, both prepared biosorbent will go into the same procedure where take a small amount of biosorbent and test them under scanning electron microscope for the morphology, structure analysis, and test for Fourier transform infrared to examine the functional group and chemical information. For the baseline determination of effluent, the procedures are: firstly, collect large enough amount of industrial effluent. Second, measure 50 ml of effluent and pour into a beaker. For ICP-MS, place the sample on the equipment and run the equipment. For the DR6000 test, perform dilution step until the DR6000 can display the result for the sample. The baseline determination step is performed to determine the initial concentration of heavy metal in the effluent. Objective 2 is to perform the parametric study on a series of factors which are pH, contact time, and biosorbent dosage. Proposed procedures for the effect of pH are: fill 50 ml of effluent sample into 8 different flasks. Make sure these parameters need to be consistent, which are temperature 50 degrees C, biosorbent dosage 0.1 gram, 60 minutes of agitation time, and 250 RPM speed. 8 different pH will be tested from pH 2 till 9, and the pH will be adjusted by using acid and alkali solution to achieve the desired pH value. After an hour, 10 ml of each solution will be taken and filled into 8 different sample cells. The fifth step is to add ferrover iron reagent into every sample cell. Let the mixture for 3 minutes before it is tested for DR6000. Result will be displayed on the screen and record the data. Next is the effects of contact time. The procedure is quite similar to the proposed procedure of pH effect. Firstly, 6 conical flasks will be prepared and filled with 50 ml of effluent. The next parameters that need to be constant are temperature, speed, and the volume of the effluent. The effect of contact time will be measured at every 20 minutes interval. After the first 20 minutes, 10 ml of the sample will be filled in the sample cell. The same procedure for the R6000 test will be performed, which the additional of ferrover iron reagent and lab for 3 minutes before the test for the DR6000. Next, the results displayed on the DR6000 screen need to be recorded. The procedure will be repeated for the next interval of 20 minutes. The last effect that will be studied is the effects of biosorbent dosage. In this procedure, the main aim is to determine the optimal amount of dose of biosorbent. First of all, prepare 50 ml of effluent in 5 different conical flasks. The experiment is conducted under the condition of pH 5 and contact time of 60 minutes. For each flask, dose different amount of biosorbent, for example, 0.2, 0.4, 0.6, 0.8, and 1.0 gram of concord biosorbent. After an hour, take 10 ml of every effluent sample and fill into 5 different sample cells. Perform the R6000 procedure test for all the samples, and lastly, record the data. Data analysis, adsorption isotopes analysis, and regression line analysis are the steps in accomplishing the objective. Firstly, data analysis is performed by repeating the procedures for 3 times in order to find the mean of each procedure. Next is to evaluate the adsorption isotope. There are 2 adsorption isotopes to be studied, which are Langmuir adsorption isotope and Freundlich adsorption isotope. Langmuir adsorption isotope is the linear model for monolayer adsorption on homogeneous absorbent, while Freundlich adsorption isotope is the linear model for monolayer adsorption on heterogeneous adsorption. Lastly, graphs for both isotopes will be plotted to determine the best fit line. The suitable isotope to use for this research is determined by comparing the square regression value for the plotted graphs. The R-square value that approach 1.0 indicates the best fit line and the most suitable isotope to be used for these studies. This slide shows that these are the list of results that is expected to be achieved at the end of the research. For Objective 1, the preparation of different biosorbents are expected to be in fine powdered form. 2 types of biosorbents will be prepared and tested to identify the morphological structure, functional groups, and chemical information for concord biosorbent. While for Objective 2, on determine the optimal parameters for the biosorbents. 3 different parameters will be tested, which are pH, contact time, and biosorbent dosage. In this objective, the percentage of heavy metals uptake can be determined by testing the samples using the R6000 test. The final ion concentration left in the effluent sample indicates the adsorption process can be performed at its best. For last objective is to determine the best isotope to be used in this study. 2 mathematical methods that will be studied is Langmuir and Freundlich adsorption isotope. The adsorption isotope indicates the behavior of adsorbent interaction which helps in designing an appropriate adsorption process. Plotted graphs for both isotopes will determine which model can have the best fit linear line which has the nearest R-square value to 1.0. Plotted graphs for both isotopes will determine which model can have the best fit linear line with the nearest R-square value to 1.0. At the end of this evaluation, line mu is expected to be the best isotope to be used. Last but not least, here are some of the references used in this research.